Hi everyone. Today I've got our PhD student Oliver with me, and the question today is how to design a vacuum chamber. And the if you design a vacuum chamber, essentially it sounds like a very complicated process, but it isn't. Yeah, and the reason for that, in modern CAD programs can be done pretty easily. In our case, I'm using Autodesk Fusion 360. And the assumption here is that you're trying to design a chamber for a CF chamber, but KF would not metal sealed one would work very similar. So CF is metal sealed for ultra high vacuum applications. And that you're not going to be the one making it, but you're going to send it to a company that will check if all of the wall thicknesses are correct, and if everything can be made. So in this case, we're not going to pay too much attention on the wall thicknesses because they might differ depending on what material it is, and for certain materials, the companies will come back to you and ask you if thicker or thinner wall thicknesses somewhere are actually okay for you. Okay, so starting point is well, if we have a vacuum chamber, usually what's important for us is where are the ports, how big are they, what angles do they have, and how do I attach anything to the chamber that's not directly on the flanges, which is usually some kind of base because you're going to mount the chamber somewhere. And potentially some inner mountings for any stages or anything that you want to have inside. And for that, we're going to start with a sketch. And we're going to do a relatively simple chamber, which is going to have a couple of ports. And the first thing we're going to do is just using the L key to make a center line, and the X key to make sure that that's not actually, we're actually going to have it as a solid line. And so in this case, we're going to make one at a couple of odd angles, a chamber with a couple of odd angles so that you know how to do that, and some not so odd angles. So this would be the basis of the chamber, and I probably shouldn't have made it at the origin, and the reason for that is that, let me redo that. Reason for that is that this is going to be the main chamber. Reason for that is that we are going to have some offsets, and these offsets are going to be the offsets from any flange that we attach. So here, this is a weld-on flange. So I've downloaded all the different flanges I'm going to need from a manufacturer, VAB in this case. If you ask them, they will give you a drawing, and they all have offsets. Yeah? So if I look at this thing, it's going to be attached to the chamber, and it's going to have an offset from the front. Yeah? So if I want to have nice measurements to the front, I'm going to have a look. So this is 8 millimeters for a CF63 flange. So what I'm going to do is I'm going to go into the Modifiers tab and change parameters. And here you can create user parameters. And I'm going to create a new one, and the name is CF63 underscore flange offset. And if you remember right, it was 8 millimeters. It was 8 millimeters, and okay, and it hasn't quite downloaded the CF100 yet. It's still downloading a lot of the flanges, or uploading really. Well, I'm just going to give it an arbitrary or reasonable value for now. So we're going to have another user parameter, which is going to be the CF100 underscore flange offset, and I'm just going to estimate it's 10 millimeters, but we might need to change that later so that we get to the right distances everywhere. We potentially in this case would also need a CF40 flange offset, and that might be 6 millimeters. Again, You're going to need to change that later on. So that here, this is going to be offset by the CF 100 flange offset. And then we're going to have a point up here, which is also coincident with this line up, and that was 4, that was 6. And then here we're going to have another CF 100 flange offset. And the reason why we're doing this is because we want to have a certain height for a chamber. Yeah. And now, how tall do we want to have a chamber? Maybe 200 millimeters. And this makes sure that later when we create the diameter, everything fits together. And for a CF63 flange, you can have a qualified guess what the inner diameter is. And this is 38, so it's 63 times 2. Yeah, no. 38 times 2, which is 76. So this is our tube diameter in this case. So this is not a regular CF63. Okay, so this is a regular CF63. So this is already one with a larger bore, which you can use. So you will find for a lot of flanges you can get them in a small bore configuration, which is the regular one, or sometimes even a smaller one, or with a larger bore, so you can get larger things through it. The problem is if you need to fasten the flange, you're not going to be able to get a box wrench around the head of the screws here, which if you need to mount and dismount the flange multiple times, that becomes pretty annoying. So don't do that unless you have a good reason for it. Yeah, so we have 35 millimeters or 70 millimeters is the diameter, which is something we can add to the parameter list. So we can go CF63 underscore tube diameter. Oh no, that was the search function. That was not actually creating a new one. So I have just changed the layout of everything yesterday. So CF63 underscore tube diameter, and this is 70 millimeters in this case. Okay, and then here this is going to be a CF63 tube diameter divided by 2. And with this we've got the base design for a CF63 tube. And I think for now, for this quick demo, we're going to stick to CF63s, because there we've got all the data here already, while everything's uploading. And now we want to have a something going out on the side, maybe halfway up. So we can go and just create something here at the midpoint. So this is just going to be something that pokes out here. And here again, same story as before. I'm going to create a point that just is out from here. Well, it's also on coincident with that line, which means it's actually coaxial with the line rather than coincident. It doesn't need to be on the line. And so here we're going to have our CF63 flange offset. So we can put a certain distance on here, and now we can obviously pick from where we want the distance to be, but let's just assume it's from the middle, and we can make that maybe 100 millimeters. So now we would have a flange that pokes out by 100 millimeters. And the next thing we're going to do is have something coming out our way here. So we might want to have some other flange that comes out at an odd angle that we're going to use a second sketch for. If it comes out straight, I could just pull a circle here and you're going to see later why I could. In this case, it would be relatively easy because you can just have it coincident here. We're going to do that with a second sketch. Okay, so base thing that we're going to do before we move on to that, and I can see we have something that's undefined here, which is the diameter here, which is CF63 tube diameter divided by 2. Yeah, so we've got a CF63 tube. And so the thing that we're going to use the most is actually a revolve command. So all we need to do for the main chamber is to select the profiles here and then the axis here and create a new body or a new component. What I usually do is I draw all of the chamber parts, I draw the chamber and finish it before I start adding things like the flanges, which are going to be separate parts, and they're not going to be part of the original part. But it's just my style, you can pick however you want. And the next thing we're going to do is actually revolve this part here about this axis, and we're going to change the operation from cut to join. We're going to change it from cut to join, and I think it's already pretty easy to see how that gives us our base vacuum chamber. And when we want to finish it, we're going to use the shell command. But before we're going to use the shell command, what we're going to do is add some port at some weird angle and potentially at an offset, so I can show you how to do a proper offset as well. And we're going to do that in a plane that's perpendicular. Oh no, that's not perpendicular. So let me just delete that sketch again. Could also reallocate it to a different plane. So in this case, we want to have it in this plane. And we're going to have it maybe poking up at a 45-degree angle or any angle we want. And so essentially what we're going to do is we're going to need to project some geometry from the base. So P for project. And what we're going to project is this point here, because this is our reference point, and the main axis here. These are the two things we're going to need in the next sketch that we're on. And now when we draw, we're always going to draw in the sketch plane unless we make it a 3D sketch, which we don't want. And so here what I can say is I want somewhere on this line, I want this to be up by 45 degrees or by maybe just by 15 degrees so that we don't run into any problems. Anyway, so we can say, okay, we want this to be also 100 millimeters and this to be 15 degrees. So I set odd angles. And the next thing we're going to do is define the offset here and make it maybe, I don't know, 30 millimeters, maybe 30 millimeters. And then we're going to do the same thing that we did before, which is create a rectangle. If you do extensions here, it will come up with the right angle here and here. And then we'll just need to put a perpendicular constraint onto here. Okay, that just needs dimensioning. So again, here we're going to have our CF63 flange offset, and we are going to have our CF63 tube diameter divided by 2, and then we can finish that sketch and do the same thing. Revolve this sketch plane, revolve this sketch thing around here, and again we want to join and not cut. I want to join and not cut, and now we've got a pretty ugly looking CF chamber. But this is pretty much most of what we can do, because we are going to have tubes that are going to be welded together at some angle, and anything deviating from there is probably going to demand a little bit more knowledge about what you do anyway. Of course, you can think about whether this is manufacturable. So if your manufacturer tells you, okay, this wouldn't work with the welds, or this would make it very complicated, just listen to them. Obviously, if you've got some welding experience, it's usually easier to know, but now this is just about designing. The next command will be the shell command. Here we are just going to designate the all the flanges that are going to be open. This is all going to be open, and I'm just going to give everything a thickness of 2 millimeters. So we're going to have 2 millimeters everywhere. Going to have 2 millimeters everywhere, and this is probably going to be okay for a CF63 flange, but larger tubes are probably going to have higher wall thicknesses. If you go into more expensive CAD systems, for example, in Autodesk Inventor, you can define it on a per flange basis. So I could say here I want to have this thickness, here I want to have this thickness. With Fusion, you can only do it in one thickness. If you want to change that, if you, for example, have one tube that you know is going to be thicker, you can use the press pull command, which comes up with Q. And then you can go here and say, okay, but here I want to have it a little bit thicker. I want to have, an offset of 3 millimeters, and the rest stays with. Oh no, it applies it to everything, so we shouldn't do it automatically. We're gonna have new offset, new offset, 1 millimeter new offset, and that used to work. I don't know why it stopped working. Anyway, you're just gonna deliver a chamber to your supplier, a chamber design that just has the same thickness everywhere, and you're gonna tell them, look, tell me what thicknesses you're going to need. Okay, so now we've got the base chamber, and the distances are all fine. And so the next thing we're going to do is go into the bodies, give it a name. In this chamber is gonna be chamber main body, and then create a component from it. The difference between components and right now our entire drawing is just one component. This is not what we want, because we're going to soon introduce new components. So we're going to go and create components from bodies. And now we've got a new component, and the component is called chamber main body, and it contains exactly that body. And we need to fix that in space. Otherwise, right now, what I would be able to do is just move it around in space, which is of course not what we want. What we want is to ground that component. And now there always needs to be one grounded component in your assembly, because this is the reference everything references to. And right now, we're not going to need these sketches anymore, so I can switch off the sketches. Because the next thing we're going to do is we're going to insert into this design after we've saved it. So let's just go up once, and here's that's named chamber. Oh yeah, it's already got a chamber in it. So we're going to save it as test chamber. Save, and then go back into the VABCF parts. Oh yeah, it's a lot more loading right now. And so this is a weld flange that is tapped. So the G stands for Gewinde in German, tapped. Always make sure that you get the right parts, because otherwise you're gonna get chambers that either have taps where they're not supposed to have taps, or the other way around, or they might be movable if they're not supposed to be movable. Anyway, so you can insert that into the current design. And then this is movable, just like the chamber was without fixing it. And I'm just going to move it somewhere away. It doesn't matter where you move it right now, because what we are going to do is we're going to join it to the chamber. J for join. You can also find it in the Assemble tab. And then we're going to take as a reference, we're going to take the center. This is where we would weld it on, and the center of this ring. This is going to be our reference. It's going to be our reference, and with the command button we can snap it to the important point. And then we're going to be able to snap it to the chamber, and we're going to put it onto one of the flanges here, so I can go onto the surface and then again move it to the middle, and off we go. And I put it onto the odd angled one, because here this is a good example. So the last thing we need to define is the hole orientation. Yeah, always make sure that the hole orientation is correct on all of your different flanges, because you're going to mount parts to it that are not rotatable, like a valve. And if your valve can't be mounted in that direction, which you can check later with the assembly, then that would be a pity. So you would have to rotate it. In this case, we've got two main orientations. You'd have to move it by 22.5 degrees, either this way or this way, or if you need it, anywhere in between. But this needs to be specified. It's very important, because your manufacturer is going to look at that and going to weld the flange to it exactly the way that you specified. Obviously, if you have rotatable flanges, it doesn't matter, because you can rotate them after the fact, but usually it does matter. So with fixed flanges, it always matters. There we go. And off we go. Yeah. And I'm just going to repeat that 2 more times, and then I'll just quickly show you how to do the design drawing for that, because that's what you're going to send to your manufacturer. Because it's nice that you send in the CAD model, but you're going to also need to specify tolerances. You're going to need to specify what's important and what's not important, and if you have any tolerances. And you need to communicate materials as well, and we'll get to that in a second. Then I'm going to switch off the component coloring, which is currently switched on. So you can see within a couple of minutes we've already designed a basic chamber, and that's essentially how long it takes. It doesn't take very long to design a vacuum chamber. It's a relatively simple design. Okay. Of course, in a real chamber, you're probably going to have multiple different flange diameters that they're using: CF40, CF63, CF16, I don't know, whatever you want to use. The very first thing that we're going to see is, of course, already, we're going to have a problem here, right? So we can barely make it fit, and actually it's touching. If you're not entirely sure, what you can do is do an interference analysis, where a computer is going to have a look if you've got any interferences. And you can see already, yes, there is an interference here. So you can see there's an interference here, which means the chamber cannot be made this way. And also, if you needed to make it close to that, you also need to be aware that you're not going to be able to put any screws through here. So if it's a tapped flange, it wouldn't matter, because you're gonna screw in from the other side. But if it's not a tapped flange, if it's a through-hole flange, then that would be a problem. So in this case, what we can do is, of course, we can go back to the design here, and we can say, okay, we're going to do that 30 millimeters, we're going to do that 25, if that still serves the purpose. Otherwise, we might need to make the chamber a little bit longer. And now this interference is gone. Now this interference is gone. Here, then, it's important to remember that different manufacturers have different flange thicknesses, so it's best to use the flange that your manufacturer uses, because otherwise you're going to have to check afterwards if the flange is a little bit thicker, if you've got any interferences or anything that doesn't work anymore afterwards. What you can do already with this design is, of course, go export it as in an external file format and 3D print it, for example. We bought a relatively large 3D printer so that we can print the chambers. And what you can also see is that they have different colors here because they have different materials. So the next thing I'm going to do is assign a physical material, because that's also going to be communicated. And the default is steel with no specification, which is, of course, we have specifications. So what we want is a stainless steel 304 in this case. So I can just go into here and move in stainless steel 304. And these components I can't change because they're not from this design. But if I want to change those, I have to go into here, open them. And I think, no, that wasn't open quite yet. And here also change the physical material. And in this case, the default is also steel, and we are going to change it to stainless steel 304. If you've got any materials that are not in the library, you can create new materials. And in this case, the material and the appearance are two different things, because of course you could have paint on it. And in this case, the appearance we want to have is stainless steel also. So remove all the other appearances and then close. And the reason why I want to have it that way is so that if I look at a model, I can tell straight away whether all of that is correct, whether the materials are all correct. Not that I have some weird material somewhere in there, because it's going to pop up in the manufacturing list. Okay, so next step that we need is creating a drawing, a new drawing from design. And in this case, it's probably going to fit on an A3 sheet, but you can change the sheet afterwards if you want to. And we want to have the full assembly, not just the visible ones or selected ones. We want to have the full assembly, but you can also pick subsets of that. And then we should get into a new drawing. Hopefully quickly. So we've got a new drawing sheet, and in this new drawing sheet we're gonna have, slowly but surely uploading, we're gonna have a model of the chamber. Usually I try for it to be a one-to-one model, if that's in any way doable. Some models are just too big. In this case we're gonna go for a 1:2 in this case, and we are going to look from the right side. I think this is a good start. And so we're going to have the base design here, and then we're going to have some views, and here we're going to start dimensioning. And the first thing we're going to do is to put a center line on here. So create a center line, and then you can used to be able to extend the center lines. How to? Okay, that's been changed. Oh yeah, no. So we can extend the center line. So we've got one center line here, and we've got one center line for here, because we are going to have to put some dimensions in. And then of course we are going to need a drawing also from the other side. The question is, do we want it from this side or from this side? In our case, for this chamber, it wouldn't matter. And here the same thing. We're going to have a center line here, and we are going to have a center line here. And always remember, this is all about communicating our design intent. This is the important thing. And we're going to have a table, and our table is going to show, okay, chamber body main, and this is stainless steel 304, and I think for the flange it just shows the part and it still says steel, so it might be that it's not saved or the changes haven't been propagated yet. And here we've got the numbers of what's what, and that is a bit odd because it's been put behind the flange, but obviously it's supposed to be this thing here. So we've got 4 flanges, and we've got 1 chamber main body. And so what do we need to communicate as a design intent? Well, the flanges, they're communicated, they're CF63 flanges, that's fine. So what we need to communicate is what the overall height of the chamber is. So we're going to go into here and click at the end here and at the end here. And apparently I measured wrong. So the flange offset needs to be changed a little bit for it to be 200 millimeters, but you can easily go back and do that. Then we want to have from the center to to the end of the flange, we're gonna have 100 millimeters, so it's odd that it worked out here and not in the height, so I might need to have a look at what I did wrong there. And then we're gonna need to communicate the angle here, so 75 degrees or 105 degrees, so whatever you wanna do, 75 degrees. This has a certain offset from some reference. In this case, I'm going to reference the bottom. That's 123 millimeters. And we're going to have to reference the offset out here, which is 100 millimeters. And move everything so that it's properly readable. And that is actually the entire chamber design. So this is what you would send to your manufacturer, because they're going to do their own design drawing for manufacturing anyway. One thing we can do is we can specify the tube diameter here. So this is a 70 millimeter tube, or we can go and make a cutaway. So we could go and make a section drawing. So we're going to go take this here and make a section drawing from here to here, and that was stupid because that was the wrong way around. That is not actually what I wanted. You're gonna make a section view from this sketch from here to here. And this would give us the ability to have a cross section so that we can also dimension the interior clear diameter if that is important to us. So this is also something that needs to be communicated occasionally. And we can put in tolerances. For example, we could say, okay, the angle is very important for us. So we can go and put in tolerances. If we double click on anything, you will get a tolerance. So in this case, we're gonna have plus minus 0.1 degree as a tolerance, and maybe also the length of the port could be a tolerance. Even though 0.1 millimeters are extremely tight tolerance for welding construction, 0.5 is doable. 0.1 degree is probably also a bit tight for a welding construction. But if you need it, then that's what you need it. That's what you need. You just need to pay more for it. But you will see sometimes on the manufacturers they have certain price lists for certain tolerances that you can ask for. And the rest is then just moving stuff around so that things are not sitting on top of each other, so you can read them properly. Okay, and that would be how you design a chamber to communicate the design intent to your manufacturer. Obviously, you can go into the design drawing and add things like mounting points and so on and so forth, but that's not really specific to designing a vacuum chamber. But this would just be a basic vacuum chamber design plus design drawing, and you would send probably a step file and the design drawing to your manufacturer, and they would make the chamber for you. Okay, and that is it. So you can go and try and knock yourself out.